Hi, everybody. How's everyone? Good. All right, so just a little anecdote. 17 months ago, I was in Tokyo, Japan at the largest wearable tech show in the world at a convention center called Tokyo Big Sight. And it was kind of a risky move because looked like there was going to be a worldwide pandemic, and a lot of people told me don't go. So my CFO told me don't go. My VP told me don't go. My wife told me don't go. So what did I do? Yeah, I went to Japan. Okay, so my question for everybody is, was that a good idea? And the surprising answer is, yeah, it was a great idea, because I met one client at that show, and that client asked us to develop a glove that could be worn and attach a scanner to the glove, and that client's customer is Amazon. So that risky move put me in front of someone who moved the needle on our business and moved us forward in the industry. So my takeaway from that, and my takeaway for everybody here, is what we're doing here today is very important. As much as virtual trade shows existed, for me personally, it didn't work for me, but this works for me. Being in front of people, being able to talk to people, being able to ask questions, hear the answers, and then answer questions also helps. So I'll take a page from a great speaker we had today, Alvaro, who said that this is much better when it's a conversation than when it's a speech. Because I can get up here and I can talk for 40 minutes and bore everybody and then go back to sleep. But that's not why we're here. We're here to learn and to explore topics. So having said that, I am Matt Kolmes from Supreme Corporation, and we develop not only conductive yarns and textiles, but we develop wearable technology systems. And you may be asking yourself, well, why should I care? Or why is that important? Or, who's this guy and why is he here? I believe it's important for one reason, and that reason is, if you can remember, some of you, like I can, back to a time when there was no GPS, if you wanted to drive somewhere, you basically put a map on the steering wheel, and you got in the right lane, and you did about 50 miles an hour, and you kept looking at the exit signs, and you took your finger and you tried to put it on the map and figure out where you are. But basically, that was a pretty poor way of getting around. And then GPS exploded, and everybody had GPS, and right now, everybody has a GPS on their phone. And so, again, the takeaway is, before there was GPS, nobody cared, right? You didn't need it. You got around without it, so why talk about it? And that is the revolution that is about to occur in the wearable tech industry with sensors. Now, in 2019, there was a Wall Street group that identified growing market sectors. And sensors in general, and especially sensors for clothing, was predicted to be the fastest growing market segment in textiles. And if it's the fastest growing market segment in textiles, then it is one of the fastest growing market segments in fashion, and therefore it's very important to everybody in the industry. So the only question that, I went too fast, the only question that you'll want to ask yourself 10 years from now is, what sensor are you using? How much does it cost? What is the performance of it? And how does it compare to what else is available on the market? But we're about to hit that moment where sensors on clothing become ubiquitous. So I want to talk to you a little bit about my experience with clothing sensors and how we're developing clothing sensors and what it means to the industry and what it's going to mean over the next 5 to 10 years. So our claim to fame, is that in 2017, we developed a yarn that conducts electricity. And it was very different from other yarn that was available in the textile industry. One, we used copper, which is highly conductive. Previous to that, people were using silver, which is expensive. People were using stainless steel, nickel, other conductors. But all of the yarn was metallized. So the outside of the yarn was metallic. And this has been used in the medical industry for decades. If anybody had electrical stimulation when they went to physical therapy, they most likely had an electrode that was connected to a power supply that got put on their body and generated a muscle stimulus. So in the medical world, conductive textiles is not new. But what we did really was new because we put the conductor on the inside. And we covered that yarn with other yarns, which is our core business at Supreme Corporation. So we made cotton conductive yarns. We made polyester and nylon conductive yarns. We made wool conductive yarns. We made silk conductive yarns. We basically, any textile that you could imagine, we were able to put a conductive wire inside the core of that yarn and make it look and feel soft and comfortable, which hadn't been done before. And then for anyone who's in textile industry or knows the industry, the hardest problem with conductive yarns is processing the yarns. So you get yarn, that's great, but now you gotta make something out of it. And the main ways that people do that are by knitting or weaving, and there's also embroidery and sewing. But the yarn itself has to go into a fabric, so it has to do something. So in 2017, we won an award at IFAI for Best New Product of 2017, and that launched a division of the company called Volt Smart Yarns. And when we launched Volt Smart Yarns, the idea was, let's bring things to the next level. And the question that we asked ourselves was, how do we do that? But the industry solved that question for us because there were lots of companies that came forward and said, is this R&D or do you have it on the shelf ready to sell? And we said, oh, it's on the shelf, it's ready to sell. And that got the industry's attention. So before we knew it, we were in conversations with automobile manufacturers that all wanted conductive yarns for automobiles. We were speaking to, surprise, people that make tablet, computers, and PCs because they all wanted a shirt that could complement the PC that could be used in health and hospitals. So the thing that jumped out immediately when we won this award was that there's got to be an intersection of two things to have a successful product. What you need is something where we call it a definite need. And that's not our term for it, that's what the government terms products that are indispensable. So if you make a screwdriver, is there a definite need for a screwdriver? Probably not. But if you have a medicine that can save your life, there's a definite need for that product. So we were looking for that classic intersection of definite need plus affordable. And what we learned is that if you create a product that people need and it's at a price that they can afford, you've got a bases-loaded home run out of the park. So we made the conductive yarn, we got into these conversations with automobile manufacturers, manufacturers of tablet PCs, and everybody was wanting to process the yarn. That led us to a FOA. I'm not sure how many people here are familiar with a FOA, but that's AFFOA. And a FOA was put together by the US government to encourage wearable technology and the development of wearable technology, and to create an ecosystem of wearable tech. We met a company that had a NASA license, and they were doing vital signs sensing on fabric with conductive yarn sensors. Their question for us was, can we use your yarn? And of course, we said, we don't know. We can try. So we put our yarn into this configuration that's NASA's intellectual property. And when NASA tested the sensors, NASA came back and said, we made more sensitive sensors out of yarn on fabric than they ever made with copper on printed circuit boards. So this was this epiphany moment where we said, aha, we're onto something. We won an innovation award, that's cool, but that doesn't really pay your bills. But two, now we can sense on fabric, and that is really different. So it's my pleasure to be here and talk to you a little bit about textile sensors and where's the market going and what can we do with those textile sensors. Okay, so NASA did it on a circuit board. And what they did, it was the invention of a physicist named Stanley Woodard. Dr. Woodard passed away in early 2000, middle of 2007. But Dr. Woodard invented Sans EC in 2003. And what Dr. Woodard figured out was that if he had small geometric shapes of electrically conductive yarn, well, he used copper on a circuit board, and he put that next to an object, like let's say a pitcher of water. He put that sensor next to the pitcher of water. He introduced a radio frequency, and what he noticed was that conductor, that copper on the circuit board, it started to vibrate, and it started to resonate, my mentor said, like a guitar string, and it started to give back a different frequency. And Dr. Woodard figured out that if he placed that sensor close enough to anything, he could read the object that was next to the sensor. So with the water example, when he put the sensor next to a pitcher of water and he introduced the radio frequency, by looking at the frequency coming back on a machine called a VNA, or a vector network analyzer, he could tell you if the pitcher was full or empty. But here's where it gets really fascinating. Dr. Woodard figured out that if he was pouring the water out of the pitcher, he could see the rate of change. And that was really unique, and that was really different. So what Dr. Woodard, and to everybody's embarrassment, Stanley Woodard was not a radio frequency expert. He was a PhD in another field. But he figured this out by accident, and he figured out that this works, and it works every time. And it's really important, and NASA needs technologies that are easy to launch into space. And this surely was a technology that was easy to launch into space. It weighs almost nothing. It doesn't have any parts. There's nothing to break. There's nothing to connect it to. And it's called sans EC. And sans is from the Latin word without, and EC is for electrical current. So if you go to YouTube and you put in sans EC, you're going to come up with about 5 or 7 videos that were put out by NASA that show Dr. Woodard talking about this field of technology that he developed. NASA spins off technology. That's one of the things that they do. They develop technology to use in space, but they want businesses to take over that technology and commercialize it. There are now 17 licensees of sans EC. We are the 16th licensee through a company called Textile Instruments out of Ohio. And so congratulations to Dr. Woodard. This technology is now used in many different industries, but it's also used on the space shuttle. And everybody, when I was a kid, we remember watching on TV in the library of our elementary school, the space shuttle exploding. Well, that was because there was a probe in the gas tank, and that led to a spark that ignited the gas tank and exploded the space shuttle. NASA uses sans EC on the space shuttle gas tank, and they read, just like Stanley Woodard read that pitcher of water, and whether it was full or empty, well, they determine whether there's gasoline in those tanks without ever putting a probe in there or introducing anything dangerous to the gas tank. So sans EC works. My mentor at NASA is a guy named Ken Dudley, and Ken Dudley retired last year. My other point of contact is George Sikowski. So Ken and George were really given the position by NASA to guide us through, teach us the technology, and teach us how it works. The funniest thing that anyone ever said to me was Ken Dudley, because Ken was a true PhD radio frequency expert, and he designed antenna systems for NASA, and he also designed antenna systems and antenna arrays that could be read from space to relay communications from the space shuttle to the space station and from the space station to Earth. So Ken knew more about radio frequency than anything, and he became Dr. Woodard's disciple. Here was a guy that knew nothing about radio frequency. NASA went to Ken Dudley and said, Ken, embed yourself with Dr. Stan Woodard. Embed yourself with Dr. Woodard. Find out everything you can about sans EC. Figure out how it works. And then figure out how do we use it and how do we commercialize it. So Ken Dudley did that. He said, you know, when I first met Stan, he saw me walking by his laboratory and he called me and he said, Ken, come over here. Let me show you something. Here's a pitcher of water, and I've got this sensor, and look at the network analyzer. I can show you if it's empty. I can show you if it's full. I can show you the rate of change if we pour the water out. And Ken said, it was interesting, but it didn't seem to me to be a groundbreaking thing that was going to change the world. But Ken didn't realize the implications of what Stanley Woodard had figured out. Okay, so now we've been using the sensors for about 2.5 years, and we've proved our concept. And a lot of things in life take time, and proving our concept with SANS-EC took time. We had to explore what NASA calls the architecture of the sensor. It ends up that we make sensors in all different shapes. We make them in circular spirals, we make them in triangular spirals, square spirals, pentagon, hexagon, octagon, and every shape lends itself differently to different types of sensing. But all of them work the same way. They work off of changes in the electromagnetic spectrum. And so I'm not an engineer, I'm sure most of you are not engineers, but basically what you need to know is that there's 3 things that these sensors measure, and they measure changes in capacitance, inductance, and resistance. So NASA suggested, when we got our feet wet with SANS-EC, that we really prove to ourselves the architecture of the sensor. So what we did was we introduced water, and we looked for changes on the network analyzer. We changed the temperature, and we looked for changes on the network analyzer. We touched the sensors, and we looked at changes in the capacitance. We made very sensitive touch sensors from SANS-EC. So now is the point where we need to develop the framework to read the sensors. And so I was fascinated by everything that came up in this conference about machine learning and artificial intelligence. And I'll tell you, none of you need to be an expert in this. You only need to have an understanding of the vocabulary, and you need to understand the basics. But basically, for me, and challenge me if I'm getting this wrong, machine learning is really the automated collection of data. So machine learning is the beginning. Machine learning is where it starts. We're really interested in something very, very different. We're interested in deep learning. And as you can see from the slide, I won't bore everybody by reading it to you, among data scientists, there's a little bit of a controversy about whether deep learning is more of AI or deep learning is comprised of machine learning and AI. I'm not going to weigh in on that fight because I'm not an expert in that field. But all I can say is deep learning is where you have the unsupervised, and that is the key word here, the unsupervised analysis of the data and conclusions drawn on what the data is. So for yarn conductive sensors on fabric, here's where it gets really cool and really interesting. We're working on applying this to challenges. Now you might ask yourself, okay, that's great, but what does that mean for me? Well, what it means for you is a lower cost of healthcare. So during the pandemic, we learned that a lot of people, myself included, and for my 3 kids, we turned to telemedicine. You know, my son had a rash. We didn't want to take him to the doctor or the hospital. Everybody there is sick with COVID. What can we do? So we got on our Aetna app and we did our telemedicine visit, and the doctor said, you need 1% cortisone cream and put it on twice a day. Beautiful. That's fine. But now we can actually deploy a fabric sensor that you can wear, and that doctor can detect your pulse, that doctor can detect your heart rate, that doctor can detect your blood pressure. With a little more development, we can probably do blood O2. We may even be able to do cortisol levels. So the application of SANS-EC to textiles is endless. In fact, the way Ken Dudley explained it to me once is, he said, SANS-EC is kind of like a rabbit hole that you go down and you never come back out. Because the more you learn, the more there is to learn, and you just go deeper and deeper until everywhere you go, you see applications for SANS-EC. But what I noticed about SANS-EC that was kind of surprising is there's cave paintings in Arizona and New Mexico where they have these shapes. And that shape actually goes back to 1500 BC Greece, where the first statue of a warrior is Theracles. And NASA pointed this out to me. And Theracles is a warrior, and he's wearing a bandage on his knee. And on that bandage is a SANS-EC symbol. And NASA said to me, what did the Greeks know about this shape that we don't know? So that's my ancient aliens kind of moment for everybody, is this stuff has been around forever. We may just be rediscovering it. But through machine learning, and we're developing machine learning now, We did an experiment, which was a very easy experiment, where we set sensors in a room, we set up a network analyzer on them, and we simply plotted the rate of change of the temperature, which is just about the easy experiment that you can do. What I learned about machine learning is that you need a very large data set in order to start enabling algorithms to run through models to give you information. And so that's really where we're at now. We're at the stage where we're building our data sets and we're looking for applications. When you get to deep learning, that's when you're, Michael Jordan, doing a slam dunk, right? If we can get to deep learning, there you go. I can put all the sensors on children in a school, and based on the rate of change in the rise of temperature in a duration, where the x-axis would be temperature and the y-axis would be time, we can predict who's going to get a fever. We can not only predict who's going to get a fever, we can actually get that child somewhere where they can get screened or get medical attention. So once you get to deep learning, this is where it gets really cool. This is like what everybody wants to talk about. Are we there yet? No. Are we approaching deep learning? Yes, we are. And so one of my jobs is to move this along until it gets to the industry. And so we had some industry partners that in 2019 that were willing to fund this research and development. And surprise, surprise, everybody I think understands that health and hospitals and military is where most technology starts, because these are areas where people will pay for something that's worthwhile. But for it to make it to athletic wear or motorcycle clothing or sportswear, it's got to really be affordable, because most of the big brands, they're marketing companies, right? And that's why we're here, right? We market ourselves and what we can do. And if you're one of the big brands, what you want is something that looks appealing and people can afford, and then you've got that beautiful intersection of I need it and I can afford it. So we were very surprised that the real push did not come from health and hospitals, and it didn't come from the military. The industry that wanted textile sensors was the mattress industry. Aha. So what was the mattress industry going to do with textile sensors? It ends up, if you go to Amazon and you Google sleep sensors, you will come up with 60 or 80 pages of products that track your sleep. Most of them are a pad that you put in between your sheet and your mattress, and it'll tell you how restless you are at night. It'll tell you your heart rate. Really advanced sensors can tell you your body temperature. Some claim they can tell you your blood pressure. I've done work with blood pressure. I believe it has to be taken from your wrist, your neck, or your ankle. Blood pressure is kind of the holy grail of sensing. But the mattress industry wants these types of textiles. Guess who else wants it? The people that make office furniture. So it ends up, if you had a chair in your office or maybe in your house, and you could put your wrist down on the armrest on top of a sensor that would tell you your blood pressure, would that be useful to you? So that's a rhetorical question, because for doctors, it's incredibly useful. What if you had sensors in the waiting room? What if you had somebody in the waiting room that had dangerous blood pressure? Wouldn't you want to know that? Wouldn't you make use of that information? What if you had somebody in your waiting room that had body vital signs that were so dangerous that you were afraid they were going to collapse? But you wouldn't know until you got them into the examination room and you started to do your examination. So when you think of what we're talking about today, or what we're going to see over the next 5 to 10 years, is sensing is going to be the new GPS. Sensing on clothing is going to be the new jump that we take to make our lives better. And anything that we can do to improve our health or reduce the cost of healthcare is truly important. And that is something that the industry will leverage. And so not a lot of jargon, not a lot of things to stretch your imagination, but for me, the learning curve was really the vocabulary to have the conversation. A lot of people who were engineers asked me, well, what is the Q? Well, I didn't know, so I had to go to Wikipedia and look it up. What is the Q of the sensors? So Q refers to resonance. If something takes a lot of energy to resonate, then it's not efficient. But if it takes a low amount of energy to resonate, then that allows for the collection of data and accurate readings with the least amount of energy and expense. So it ends up that the yarn sensors have a very, very efficient cue. And that becomes important when we start to make things. And so how do we apply this? It ends up that there was a UBS Payne-Weber presentation that I attended in 2019, and they talked about technologies that were no longer new. And one of the technologies that they discussed that was no longer new was AI. So in 2019, UBS Payne-Weber claimed AI has been around. It's been around for more than 10 years. A lot of industries are using it. The insurance industry uses it. Healthcare management uses it. Financial companies use it. But AI is no longer new. AI is mainstream, okay? So now we've got to adopt textiles, marketing, and fashion to incorporate AI. And I was very pleased to see at this event that a lot of people know this, and a lot of people are talking about this. And it's important enough that I think everybody should be thinking about how to use AI. Whether you're a marketer, or you're a brand, or you're a designer, or you're an engineer, we can all avail ourselves of this technology. And so, obviously, it's a facetious question on my part to say, is it easy? No, it's not easy. And here's why. We walk through the progression of machine learning and the overlap between AI and deep learning, okay? For machine learning, you need a large data set. To really enable machine learning, it depends on the variable that you're measuring, but I think you probably need 100,000 measurements to get to machine learning. Well, if you want true AI, you want unassisted deep learning, you need an absolutely huge data set. And so here's another thing for everyone to think about as they're thinking about AI and how to incorporate AI into what you're doing. It ends up, at the end of the day, the data set is valuable, okay? Google knows this. They've got probably the largest data set of anybody in the world. They've got every Google search you've ever done. Don't take their word for it. They've got it, okay? Everybody knows what you're searching for. You know who's got another really big data set? They got into a little trouble for it. Facebook. Facebook has a really big data set, and Facebook can tell you what political ads you've clicked on, how many seconds you looked at that ad, and what you did right after you disengaged, okay? So we need to apply AI, and to do that, we need to measure the data, we need to clean the data, and what I mean by cleaning the data is you get rid of the outliers. So for a lot of things that we do, this is the development process that we're in. We're cleaning up that data. We're looking for a really clean data set, and we need data scientists to apply it to what we're doing. That's how we're going to apply it. And then the next question is, what's next? So for us, what's next is things that can improve your life. There was a product that came out in 2017, 2018, and I actually know the company that did it. They're a great company. And it was a band that went around a baby's ankle that could tell you the baby's heart rate and the baby's temperature. The problem with it was babies didn't like it, and they would try to kick it off. And so it became like something irritating to the infant that the infant didn't want to wear. What we've engineered is what we call a smart BandAid or a smart bandage. And it ends up that we can put a SANS-EC sensor on a bandage. And no longer in the hospital will you need a doctor or a healthcare practitioner to go and do a physical examination. They no longer have to unwrap that bandage and observe your skin. By reading the frequency that's coming off the sensor, someone at a remote location doesn't even have to be at the hospital. Somebody somewhere else can watch that bandage and they can say, aha, this patient is going to get an infection. We need to start antibiotics on this wound. So smart bandages are what we're looking for. We also proposed to the National Science Foundation that we do a study to try to detect COVID symptoms on human beings, and we were invited to write a SBIR proposal to do that. That deadline is in September, so keep your fingers crossed for us. But these are the applications that move the needle. And in my humble opinion, This is where the industry is going. The industry is going towards sensors integrated into clothing. And we're no longer, when I say we, I mean Supreme Corporation and our partners who are on these projects. We're no longer interested in individual products. And hopefully that's meaningful for everyone here, because my point is, we are interested now in platforms of products. We're interested in platforms of products that can reach across many industries, that can be applied in many different ways. NASA wants to apply it to astronauts' vital signs in space on their base layer. We want to apply it to mattresses and furniture and children. We want to apply it to bandages. But this is where we are. It sounds like it's something straight out of a science fiction movie, but it's real, and it's happening right now. Everybody talks about IoT. IoT is a big buzzword. IoT is actually something that pervaded marketing years ago. IoT is big in retail because you can track how long somebody looks at an article of apparel before they buy it. There's ways to put sensors on hangers and tell you who took something off in the store and how long they looked at it, and did they try it on, and how long did it take before they put it back. The need for the data is valuable, and that need is not going away. So why should you care? Well, Google cares. You know, Google has Project Jacquard. A lot of people scoffed at Project Jacquard. I wasn't one of them. They've got Dr. Ivan Poporyev, who I got to meet, who's one of the most brilliant scientists in the area of wearable tech. Google has incorporated this into their Project Jacquard jacket, where you can use your sleeve like a capacitive sensor, and that's an example of it. You can slide your volume down, you can slide your volume up, you can answer a call, you can disconnect the call, but Google understands this. Google understands the power of wearable technology, and I think all of us should become aware of it. There's a famous article on the adoption of technology, and I forgot who wrote it, but I'll look it up, and if you want to email me and read it. But basically, it shows a bell-shaped curve, and it shows that 21 to 22% of people are early adopters of technology. And then there's this gap, and the whole rest of the world is on the other side of that gap. And they call bridging that gap crossing the chasm. And what they said is, anytime a technology is new, there's going to be a lot of skeptics, and there's going to be very few people that are enthusiastic about new technology, and there's a lot of people that culturally will say, I'm going to wait till it's proven and refined and perfect, then we'll use it. And in some ways, I'm guilty of being a late adopter of technology. But when it came to Sans-EC and sensing on fabric with conductive yarn, I was all in. I was a big fan of Project Jacquard. Project Jacquard, they continue to update and improve their capability. Every year, the products get better. And in my opinion, this is the direction that the industry is going in. So my name is Matt Kolmes. I'm passionate about wearable technology. This is all I do, is develop conductive yarns, conductive fabrics, and products. And it was really a pleasure to be here today and to see everyone here moving the industry forward. Just like my example about being at Wearable Tech in Japan at the beginning of the pandemic, this is what we need. We need to be face-to-face, we need to talk about the issues, and we need to move the industry forward. So if I have time left, I'm happy to answer questions, or call me out on something, tell me I'm wrong. I make mistakes all the time. If I don't know the answer, I'll Google it. Yeah. Anybody? I have
a question.
Sure.
So congratulations first off on the amazing work that you're doing. I love the concept of combining the textiles and electronics. My fear is, again, I'm sure you know more about it, but my fear is, are we combining two of the most polluting industries where we're trying and struggling to reduce the waste, and is that going to even increase the problem that we have in the fashion industry of waste, and we have the same electronic waste? So are you considering that? I come from a background of fashion, textiles, and sustainability, and that's why I asked this question.
So that's a really great and provocative question. I'll answer it this way. From the yarn side, no. From the yarn side, we can recycle our yarns. We can actually remove the wire. We can remove the cover, whether it's cotton or polyester or nylon. We can find clever ways to reuse the yarns. When it comes to circuit boards and batteries and connectors, the whole challenge with wearable tech is that there is no one company that has everything. Like, my company may have the yarn, your company may have the connector, but we don't have the batteries. Or you may have the batteries and I have the yarn, but we don't have that little LED, or we don't have the sensor that's going to make the product work. So the challenge, I think, is going to be on the electrical side, and being able to find a way to reuse the batteries or recycle the batteries, recycle the connectors, and that may be a real challenge. And I think that's a very salient point and a very good point.
So I have like a follow-up thought on that. Because what we are struggling with different industries, including fashion, textiles, and electronics today, is the way we have designed the systems. We never thought about the end-of-use phase. We never thought about the continuous use phase, and putting it into that circular interaction. So my point is, if we are at the very starting point of this industry, why don't we kind of consider those end-of-life options and make sure that we're able to solve the problem to the core of it, not kind of create another problem by solving some of these issues?
Well, first of all, I want to applaud you for thinking about that, because very few people deal with problems before they arise, and especially in industries like textiles. We work on recycling things after landfills are full, and we don't know where to put stuff. So challenging ourselves to think about that now, I think that's a fundamental key concept. I don't have the answers for that, but I like the way you're thinking, because only by creating what they call a full cycle product, right? I think it was Adidas came out with the first full cycle product. And they had a sneaker that when you were done with the sneaker, you could recycle that sneaker and you could use 100% of the material in other products. That is the goal. And that is critical if we want to keep ourselves efficient and keep the planet clean. Otherwise, you're right, we're going to have a whole bunch of waste, and then we're going to have to get clever or creative with how we dispose of the waste. So I think that is the number one challenge for the wearable tech industry, is how do you do it in a way that is intentionally efficient and good for the planet and good for the industry?
And that's why it's so important to have these conversations now, where we are at the infancy, instead of kind of reaching to that maturity.
Absolutely, and I'd like to, just to illustrate your point, I'd like to give everybody the example of batteries. How many people here dispose of batteries, and do you do it the right way? Do you bring it to a battery collection point? How many people, and when I was a kid, sure, I did it too. We threw batteries away. We didn't know any better, but you can't throw batteries away. And that's something that people have never really tackled, and that's a related topic that is a huge problem now. And especially if you look at lithium ion or lithium polymer batteries that can catch on fire, that's a lot of waste. So yeah, this is something that we need to get intentional about and plan ahead for, not when it's too late, or, oh, by the way, we've got a toxic problem because of the waste from the industry. Fantastic question. Yeah. Anybody else? I'm sorry. Well, I'm Matt Kolmes. Thank you very much. This is the most fun I've had in 17 months. Thank you.